did is I kind of laid out the line with this guy 5 inches from there. So you'll see these are not, you have room to go here. So if you need to move these around a little bit, you can do that. You know, you can get these, you should have room to be able to fit everything in there. This is where we have our main, well, I guess this is electrically pertinent here. Our main negative inverter line, and then there's a line that goes down through the floor and out, and you'll see it if you were to roll underneath there, you'd see that's the main chassis ground.
Okay.
The main chassis grounding point. So I needed to take a notch out of this here.
Okay.
So you'll just want to take a notch out of your shelf. You'll probably have to notch your shelf a little bit and then cut the verts or whatever you need to do there to get that to fit. But I think that's the only spot that you're going to need to do.
Okay.
So yeah, so I'll just kind of do the general talk here. You know, of course, this is your bank. We have this thing wired in parallel. So we just jumpered all the negative together, all the positive together. And then the key with this setup is that you have the positive and the negative that actually power the system coming out of opposite ends of the battery bank. That's a mistake people oftentimes make. So we got this coming out here, that going out there, so that we have a complete cycle so that the batteries are evenly discharged as you go through the system. So coming out here on the positive end, we have a fuse. We have a 300 amp marine rated block fuse, MRBF fuse. That will just stay right there. I've never had any of these things blow. These are really just protecting things for like an absolute catastrophe. There's no reason that this thing should blow. But if it does, it's a lot cheaper than everything else frying out down the line. So you come out of this, you go to your main DC connect switch. And this is just a simple on and off. There's really very little standby loads, almost no standby loads, meaning some setups will have devices that are left on and there's a little bit of voltage flowing through them. And so if you leave them on for a long time, you know, if you're like, say you're not using the van or something like that, it could draw your batteries down. There's very little loads. There's like, I mean, I don't even see any LED lights. I mean, there might be an LED light on the inverter end, you know, or I suppose there's a little load on the inverter here, like probably like a watt or two. And it might add some information about standby loads in this. You know, you got a little light on there, on the GFI there, but very little. So unless you're not going to be using the van for a couple weeks at a time, there's really no reason you should need to turn this on and off. You can just leave it on.
But when I do park it for a month and a half when I'm in Hawaii working for the summer, I should turn. That's the main.
Just turn that off right there. Yeah, and essentially, what I would do, and actually maybe when you do that, give me a shout. Feel free to give me a shout.
Okay. We
can kind of get a sense of timing, and does it make sense to leave the solar system on and that type of thing.
Okay.
If you're going to park it like indoors and it's just going to be in storage and it's for like a kind of a known period of time, I'd be inclined to just shut everything off. You can just go through all these breakers here, shut everything off.
I see.
And just so
instead of just doing the main.
Instead of just doing the main, because if we only do the main, you could potentially still have some solar load coming in. It should be stopped there, but I've had some situations where if you have the solar panels exposed where there is some flow of energy, essentially.
Okay.
So again, but it kind of depends on the situation. If it's for a few weeks, it's probably not a big deal. But if it's for a longer period of time, I just always feel more comfortable if I just know what is happening. And by knowing what is happening, if it's not being used, there's no reason to have energy flowing in and out of the batteries or the whole system, right?
Okay.
So each of these things is controlled. Essentially, at the end of every one of these things is a fuse or a breaker. So, for example, we have the main coming in here, main power on off. It goes into the positive bus bar. Then out of the positive bus bar are all these different, you know, everything is red and black, so it's all very clear visually to quick see. Say this one comes out of here, and boom, it goes to this breaker here. This breaker right here then goes, and this powers your DC fuse block. I didn't label it. It's pretty clear where things go.
Sure, no worries.
If you have any questions, you just let me know. But it's really just, you know, you got a load on. If you want to turn it off, boom, I disconnected it right there. That's all I got to do. Then to reconnect it, pop.
Okay.
You're in. So this is I don't know if you just heard that beep right there. This is the sound that I love, because I don't do any testing of my components until I like literally turn the switch. So we'll disconnect this. Now listen for a second when I do this. Hear that beep?
Yeah.
That's your fan.
That was my fan.
Yep.
I know that. I know that. I know
You
that
know
sound.
that sound,
Yeah.
right? So that says, oh, I got a happy fan. The fan's
Okay.
powered up.
Cool,
Beautiful.
cool.
So
Okay.
that's my green light right there. Of course, I check everything else to make sure.
And the water
that's green
pump's
light.
hooked up through that as well.
Yes.
Okay.
Yep, and we'll show you. I'll show you that over here. Got 2 fuses in here. Your fan is fused at 10 amps, and your water pump's fused at 7.5.
Okay.
That's typical, so that should be just fine. You got lots of room more. You have 10 more slots, so you can add whatever you need to into there at any point. Piece of cake.
Okay.
This is the same thing, same breaker here for your
the AC.
AC over there, and I tested that, and that's very cool. That's
It's
nice,
where-
isn't it, man?
is
That
it good?
thing's kicking. Holy crap!
Well, you know, I
Oh,
want to spend some
beautiful.
time in the desert. I want to make
man.
sure I got my business tended to.
Yeah,
you
you're
know?
gonna love it here.
Okay.
This one, so the breaker, and then we have a breaker. We can get around to the other side there. There's for the solar system as well. There's
Okay.
multiple breakers there, which I'll show you to control everything. This coming out here, this other 2-aught gauge wire here comes onto a big old fuse, which is called the Class T fuse, and that is what we use to fuse inverters.
The inverter.
The
Okay.
reason we have that is because this is an extremely fast-acting fuse. It's a high-capacity, fast-acting. You're typically powering important electronic things with the AC power, and we don't want that to have, like, if there's a short, if there's too much juice in there, we want it to die like immediately, because otherwise you'll fry everything downstream. Right?
Okay.
So that's why we have this particular kind of fuse as opposed to a lighter weight breaker. So getting into so that's talking to you about the inverter here. I'll talk about the AC end of things, the alternating current end of things, as opposed to the DC, direct current, battery operated end of things here. So this is the main in your system, because we had a fairly simple AC side of things. I was able to just have it all built into this little box right here. You see these 2 lines right there?
Yep.
Shore power, 30 amp, and the GFI receptacle, 20 amp.
Okay.
So this is your shore power coming in right here. It goes into this 30 amp breaker right here, and it comes out right there, goes into the inverter, comes out of the inverter through the GFI receptacle. Boom, it goes into on that line right there. It goes to this 20 amp breaker. Comes out, and it supplies this right here, which is your 20 amp GFI breaker.
Okay.
Yep. And so you got a green light. That's a good sign. If you ever need to test it or do anything with it, you can just turn that off right there. Reset it like this. If it trips on its own, there'll be a red light.
Okay.
So if it trips because you get GFI protects, like if you get if you have stray current because of typically water, like moisture or something like that. If you're doing a power tool, or if you're in a house situation, you're blow drying your hair, you drop that in the tub or something, you don't want to be fried, so it just kills it in like 0.0005 milliseconds or something at the time.
So it's a 20 amp outlet. So that's basically where I'm going to run my power strips toward the front when I need to use 110
Exactly.
resources. Yep. I mean, as long as I'm not going to overload it, because I know not to plug a bunch of stuff in, but it'll be hard to do that 20 amps.
Yeah, exactly. 20 amps. I chose to put 20 amps because you have a 3,000 watt inverter, so you can support that. I'm always a little conservative with the alternating current loads. You don't want to put on like an induction cooktop and a coffee maker likely at the same time. If you're if you're kicking like 1,800 watts out of that, I mean, even if alternating current devices, typically there's a surge when they first turn on. So if you turn multiple things on at once, that surge could likely trip it. And it might trip here or it might trip here. There's different places it could trip depending on where in the system that surge is. But I've had nobody report any problems with their inverters, 2,000, 3,000 watt inverters, because people typically aren't running massive stuff off of it, And when they are, it's typically like an AC and they're plugged in a shore power anyways. And you have yours is all DC operated anyway, so it's kind of a separate system here. But yeah, you're going to plug in your power strip there and you'll be able to run a lot of stuff off of that.
Okay.
So these will just stay on pretty much all the time. These are just safety measures, if you needed to. Yeah, I mean, essentially we plug in a cord to your shore power, right? So if you want to unplug it, you want to disconnect the power, you typically just unplug it. But if for some reason, I put this in here, and we put these in the systems, if for some reason you were hooked up to say a 30 amp shore power at a campsite or something like that, and for some reason there was a problem on that end of things, they call it the utility, if the utility surged, well, this is going to protect that from frying everything downstream.
Okay.
But in practice, like again, if you're putting it into storage, I would just get in the habit of just turning them off in storage. But this is actually all powered through your DC. So once you throw this, all of this is dead.
Okay.
unless you're plugged in. But you're going to know if you're plugged in. You
Sure.
know what I'm saying? So,
Sure.
So it's just thinking like an electron, thinking of how the energy is going to flow. Just always be aware of what it is once.
Okay.
You know.
And so when I'm plugged into shore power, obviously I'm running off of that. It's also charging the batteries in the same at some level, equal level, or some kind of.
Exactly. Yeah. This is a good. It's a nice inverter. It has what they call the bypass feature. It has some advanced features. You know, all these modern inverters and like this one have. Say you're plugged into shore power and you have. What would I say? What's the scenario here? So you're plugged into shore power, you're running maybe some DC loads, or maybe you're running an AC load that's higher, or there's basically ability, instead of it going into the shore power, into here, into the battery, and then back out to the inverter to do it, it just bypasses it.
Okay.
And what that means is that instead of going into the DC system, it just powers it directly. It's like it bypasses the battery, and it powers it directly off of the AC shore power.
Okay.
So you say if you happen to have 30, most of the time you're just gonna have 15 or 20 because you're gonna be plugged in like a household, like you know, somebody's garage or something like that. You're gonna be plugged in. But say just say you're using, you got 15 amps, right? So 5 amps of that could be going to your battery to charge. 5 amps of that could be used to power loads that you have through your either AC or DC. And it has a, you know, of course, a number of chips in there, so it distributes it in the most efficient manner.
Gotcha.
To avoid unnecessary wear and tear and stray voltage run around. You know,
Okay.
It just bypasses as need be. And I talk about it a bit in the user manual, but it's pretty simple. It's kind of you don't need to do much about it. Yeah.
Okay. Good deal.
Which is good. Yeah, it's a nice product. And it's happy to see it's a good one.
All right. Good. All right. I'm gonna.
What else? Yeah, I don't think there's anything immediately here to talk about. You can.
Yeah. Let's go around the
stop
front.
and
We'll
go
check
on
out
the
what's
other
going on.
side.
Yeah.